Today my topic is about the motion of charged particle in a magnetic field. Here we consider the particle is moving at right angle to the field. First, that is the particle moving at right angles to the magnetic field. This is the first consideration. Let a charged particle of mass m and velocity v is moving a circular path of radius r under uniform magnetic field. Here the velocity and the applied field are at right angles, hence theta equal to pi by 2. So force due to magnetic field is that is Fm equal to q Vb sin theta qv sin pi by 2, that is Fm equal to q Vb. Fm means that is magnetic force. So centripetal force that is Fc equal to mv square by r. Now that is mv square by r equal to qvb, that is qvb. So r equal to mv by qv. So this is the relation of radius. So the radius of the circular path depends on that is number 1, mass of the particle, number 2, so that is the mass of the particle, velocity of the particle, charge of the particles, and number 4, that is field strength of the magnetic field of the magnetic field. So next we can write, that is time period of rotation of particle, time period rotation of the particles, that is t equal to, we can write 2 pi r by v. So 2 pi r by v, so t equal to, that is, we can write t equal to 2 pi by v, putting the value of r, that is mv by qv. So that is t equal to 2 pi m by qb. So n equal to 1 by t, that is qb by 2 pi m. So this is the frequency f, that is frequency, n, that is frequency, omega, that is 2 pi n, so that is bq by m. So this is the relation of time period, frequency and angular velocity. Omega, that is angular velocity. So here this is the relation of t, frequency, t that is time period, n that is frequency, omega that is angular velocity. Second case, we draw the diagram. Here case number 2, that is particle is projected at an angle theta with the field. So this is the case. This is the second case. So here we can write, that is, here the particle, so required, so force due to magnetic field, Fm equal to qvb sin theta, that is qvb sin theta, and Fc centripetal force, so we can write centripetal force, we can write m v square sin square theta, mv square sin square theta by divided by r. This is equation 1, this is equation 2. Fm equal to Fc. So we can write Fm equal to Fc. Fm that is QVB sin theta, that is m v square sin square theta by that is r. So here that is r, we can write m v square sin square theta divided by that is q v b sin theta. So r equal to, we can write mv sin theta by that is qb. So this is the relation of radius of orbital path. So t equal to, we can write that is t equal to 2 pi r by v, that is v sin theta. So we can write that is 2 pi v sin theta, putting the value of r in this equation. So mv sin theta by qb. So we get the value that is t equal to 2 pi m by qb, 2 pi m by qb, and n that is 1 by t, that is qb by 2 pi m, and omega that is 2 pi n, that is 2 pi qb by 2 pi m. So omega equal to, we can write that is qb by m. So here we get the relation. So this is the relation of t, this is the relation of t, time period. So when the particle is projected at angle 90 degree, then the radius becomes, this part will be 1, so mv by qb, and then this value, this is t, n and omega are same if it is projected by an angle pi by 2 or by an angle theta. These are same, only difference between that is the radius of r. So radius varies. If it is projected with an angle pi by 2, then r becomes that is mv by qb, and by an angle theta, then we include in this part that is sin theta, this mv sin theta by qb. So next we have to know that is what is pitch. We have to know what is pitch. So the pitch, so the pitch is defined as, pitch is defined as the linear distance, linear distance along the direction of b, in one revolution. This is the h. So we can write that is h equal to, that is v cos theta into t, v cos theta into t. We can write that is v cos theta, তাহলে v cos theta into t, that is 2 pi m by qb. So here that is H equal to here 2 pi mv 2 pi mv cos theta by that is qb. So this is the value of H. So this is the value of H, that is 2 pi mv cos theta by qb. So if from this equation we that is the pitch of the helical part depends on the angle theta. Here we consider some phenomena, that is first one, when the particle when two particles have same velocity, then we can write that is r1 equal to m1 v1 by q1 b, and that is r2 equal to m2 v2 by q2 b. So here we can write that is r1 by r2, that is r1 by r2 equal to m1 by m2 into v1 by v2, that is q2 by q1, that is same velocities, that is r1 by r2 equal to m1 by m2 into q2 by q1, v1 equal to v2, that is same velocity. So number 2 conditions, same momentum, when two particles have same momentum, same linear momentum, so we can get the value, that is r1 equal to p by q1b, r2 equal to p by q2b. Here p, that is linear momentum. Since linear momentum same, so we can write both case, that is p. So r1 by r2 we can write that is q2 by q1. So this is the relation. One thing we have to remember, that is field is same, field is b constant. So in both case field is constant. So both cases field is constant. So we in the both case, that is bb and here there is bb, field is constant. Today the class is now ended. I think all students have been benefited by my lecture. Thank you all my dear students.